So now let me summarize what we have. So we have y equals arc sine x, right? And this y is always between negative pi over 2 to pi over 2. So in other words, the terminal side should be in the fourth and the first quadrant. And the input x is always between negative 1 and 1. So y equals arc sine x, that means sine of y should be equal to x. Another one is arc cosine x. So this one y is from 0 to pi. So which is in the terminal side should be in the first and the second quadrant. And this x is between negative 1 and 1. Y equals arc tangent x. So that means tangent of y should be equal to x, right? And this y is between negative pi over 2 to pi over 2. So that means the terminal side of this angle y should be in the fourth quadrant and the first quadrant. And x could be any real number. Okay, you should be very careful for this one. Okay, so now let's look at some operations, right, for the arc sine, arc cosine, arc tangent. So let's recall that if we have a function f and its inverse, f inverse, then we have this property, f of f inverse of x should be equal to x. And f inverse of fx should also be equal to x, right? And this x and this x are different. This x is in the domain of f inverse, which is the same as this x. This x is in the domain of f, which is the same as this x. Okay, so they are different x. So now we have the properties, similar properties, because here we have the inverse functions, right? So the first one is sine of arc sine x is equal to x, right? We know that this arc sine x represents an angle. That means if you take the sine value of this x, this angle, then it's equal to the input x, right? So it's equal to x. And this x is from, because this x is the same x of this one, right? So it's between negative 1 to 1. Arc sine of sine x. So it's equal to what? Equal to x, right? So this x is the same x as this one, which is represent an angle. And this x is the value of arc sine. So we know that this angle, this should be from negative pi over 2 to pi over 2. So you can see the difference between the upper x and the lower x, right? This is one group. Another group is cosine of arc cosine x. Arc cosine x represents the angle whose cosine value is equal to x. That means this one. Okay, and this x is between negative 1 and 1. Arc cosine cosine x. Okay, so it's equal to this x, and this x should be between 0 to pi, right? Because this is x is in the range of arc cosine. Arc cosine is from -1, always in the fourth and the first quadrant, which is from -pi. Now, I'm sorry, it's in the first and the second quadrant, so it's from 0 to pi. And the tangent of arctangent x should be equal to x, right? And this x is from -infinity to infinity. It could be any number, right? The tangent value could be any real number. Arc tangent of tangent x should be equal to x. This is true for x is in the from between -pi/2 to pi/2. Okay, so now let's look at some examples. We want to know arc sine of 3pi/2. Okay, so we cannot, the one thing is it's not equal to 3pi/2. Right? Some students may ask, okay, why it's not equal to this one? This we have this formula, right? But keep in mind that this x should be between -pi/2 to pi/2. But now our x here is 3pi/2, which is greater than -pi/2 to pi/2. So the idea is, let's calculate this one first. Arc sine of what? -1. Okay, so this represents angle whose sine value equals -1, but between -pi/2 to pi/2. So this one must be equal to -pi/2. So you can see it's not 3pi/2, right? Or you can just convert this angle to be an angle between -pi/2 to pi/2, but they have the same sine values. So we can find the coterminal angles, which is, we might 3pi/2. So this, okay, we can write more. Arc sine of sine, let's see, 3pi/2, we subtract 1 revolution, it will not change the value, right? Because it's the coterminal angles. So this one is equal to arc sine of sine -pi/2. So this is -pi/2. So let's look at another example. Tangent, arc tangent of -5. It's equal to, so here is this one, right? So this x is could be any number. Okay, so -5 should be 4. Okay, so it would be equal to -5, right? Cosine of cosine inverse of pi. Okay, the reason is here, this pi is greater than 1, right? We know here this pi, this position should be between -1 and 1. So this one is undefined, because the cosine inverse, the domain is from -1 to 1, but your input is pi. So it's outside the domain, right? We look at, so far we have some special angles, right? You can always do that. However, if you have no special angles, Let's look at this one. So we have this cosine, cosine inverse, tangent, tangent inverse, or sine, sine inverse, sine inverse and sine, right? So if we have tangent and arc cosine, this kind of things, we mix together. Tangent arc cosine 2/3. Okay. So how to do that? So since arc cosine represent an angle, so we let our u to be arc cosine 2/3. Okay, so this angle is we can draw a right triangle, and this is the u, right? It's the cosine value is positive, so it must be in the first quadrant, right? So this angle is u. Okay, so if this angle is u, so that means cosine of u, it means cosine of u should be equal to 2/3. So we use a triangle. So if we set here is 2, here is 3, right? Then the cosine u equals 2/3. So we can use the Pythagorean theorem to find this side, which is square root 3 squared minus 2 squared, which is square root 5. Okay, so it becomes tangent to u, right? Tangent arc cosine 2/3 becomes tangent to u. Tangent to u equals what? Equals the opposite over adjacent. Right, so you have this one. Another example. Cosine of arc sine -3/5. Okay, so again, we let our u to be arc sine of -3/5. -3/5, so this one is u is, so that means sine u is -3/5. This is on the interval from -pi/2 to pi/2. So this side, the terminal side, must be in the fourth quadrant, right? So this is the u, right? So it has this one, right? So it's the -3/5. So here must be the -3, right? -3/5. 5 is always positive. So this is the distance, right, from this point. So it's 5. So but here this point has the y coordinate -3. So we denote -3 here, right? So we have this side is, so the unit is 3, right? The length is 3, but it's below, so we denote by -3. So this side is square root 5 squared minus 3 squared, right? So which is equal to 4. So our problem becomes cosine u. Cosine u is what? U is from the adjacent over hypotenuse, so it's 4/5, right? We always use triangle to help us. So arc sine arc cosine 3x, where x is between 0 and 1/3. So 3x is between 0 and 1, so no problem. So we can treat this one because it's positive, so we can treat u as if we let u to be cosine 3x, right? So this is our u, and it's equal to, so that means the cosine u should be equal to 3x, right? So this side would be 3x and this side would be 1. If we use the Pythagoras theorem, it becomes 1 minus 3x squared, which is 9x squared. Okay, so our problem becomes sine cosine 3x is equal to sine u, right? Sine u equals opposite over a hypotenuse, so which is this number. Okay. Okay, so now let's look at so this is odd and even function. Even function. Okay. Yeah, we will not discuss this part. Yeah, here the one thing I could see something about this arc sine x, which is arc sine, which is the graph will be this one, right? Here is 1, and here is pi over 2. Here is -1, and here is negative pi over 2. So you can see this graph is symmetric with respect to the origin. So arc sine of negative x should be equal to negative arc sine x. And the same thing for y equals arc tangent x. Arc tangent x would be, it looks like this one. This is pi over 2, this is negative pi over 2. It's symmetrical with respect to the origin. So arc tangent negative x is equal to negative arc tangent x. Okay, sometimes this property can help you to deal with the negative sign a bit. Okay, we have another example. We have the tangent of arc cosine of negative 2 over 3. What's that? We know that let u to be arc cosine negative 2 over 3. So that means cosine u is equal to negative 2 over 3. This is on the interval from 0 to pi. So our u should be, the terminal side should be in the, this is our, in the second quadrant, right? This is 0, this is pi over 2, right? cosine on the second quadrant is negative number. So this is our u. Okay, so we have this point on the line, which is this is corresponding to what? This is corresponding to negative. Sorry, we don't know yet, but this is corresponding to the negative 2, and here is 3, right? Here is 3. The distance is 3. So what is the corresponding y values? So we can treat this as our right triangle. So we can use the Pythagorean theorem for this right triangle to get the distance here, right? So this is the square root 3 square minus negative 2 square. So sorry, it's just plus 2 and negative 2, it doesn't matter, right? So it's square root of 5. So here is square root of 5. Square root of 5. So this point is what? Is negative 2 square root of 5, right? Okay, so our tangent to u is equal to what? Tangent to u equals y over x, which is square root 5 over negative 2. So that would be your answer for this problem.